So today I'll be talking about Angular versus React and out-of-the-box comparison. So what do I mean by out-of-the-box? You know that feeling when you just get some new gadget and you open the box, and that's your experience. You don't need to read blogs, you don't need to watch videos, you don't need to do anything. I mean, you can do all those things, of course, but that's your initial idea of the product, and that's your initial experience with it. So software frameworks are kind of like that as well. When you go to their website and you kind of do the first tutorial, that's your out-of-the-box experience. You can take most software, especially in JavaScript, and make it into something that's totally not meant to be, which is why when we're comparing Angular and React, we can't do an apples-to-apples comparison because that would be comparing two different things. And in order to try and compare them apples to apples, we'd have to deform them from how they're meant to be used. So we're not going to be trying to do that. All right. So what we're gonna do though is we're gonna try to strip it down to their cores a little bit and understand how they work at their cores. And hopefully they'll give you an understanding of what the differences and similarities between these two frameworks are. All right, so who here works with AngularJS? All right, so that's about half the room. Who works with Angular? Who knows the difference? So this is a very recent rebranding that happened. AngularJS now refers to Angular versions that are 1.x, otherwise also referred to as legacy Angular. There are still 1 million users on it by Google's count, so there are lots of users on it. And Angular is now on version 4, and it has about 800 users. So Angular is a platform that's going to keep growing. So the version numbers are going to get out of hand pretty quickly. But the major version numbers does not mean that the framework is being rewritten from scratch every time. It just means there may be breaking changes along the way, but it's going to look largely similar. And who here works with React? All right, a few hands. And has anyone heard of React Fiber? So there's right now React is on version 15, and around version 16 or 17, they are completely rewriting the framework, but they're keeping the APIs consistent, so applications shouldn't break, and they're introducing some new ideas into the framework to make it a little bit easier to work with. So today we're going to be comparing Angular to React 15. All right, so how do we go about comparing two massive frameworks? We have to look at their purpose, what purpose they serve, the context in which you use them, the features that they bring to you, the code architecture of how you would put together these applications, tooling, and the support that you will be able to get from the community or the internet. So this is going to be a bit of a journey, and I'm going to try my best to mix in theory, concrete examples, and code as we go along. And if you have any questions, or if I say something completely false per your experience, please raise your hand and share your own experience, because these are highly subjective issues. So let's go right into it. It's not easy to get into it. Let's try it again. Okay, that's a little bit better. So with JavaScript, we need to be comfortable falling flat on our faces. It's okay. You know, it's all brand new. It's all changing quite often. So there's no shame in not being perfect. And the idea is to be able to iterate, however, and refactor and rewrite often enough so that we can correct our initial mistakes and result in a good experience for your team and yourself. So I gave a talk at NGConf about a month ago in Salt Lake City, and I talked about doing more with less JavaScript. And the gist of my talk was you want to get to a point in regards to JavaScript by reducing your surface area and become like this woman here, who's able to worry about more about drinking her tea than the guy she's fighting. So we want to become that type of a master who knows what they're doing. All right, so let's talk about purpose. Anyone have a guess at which website this might be? Google AdWords. Do you know how much revenue this application is responsible for? About $22 billion per quarter. So this application is built in Angular, and it's built by Google. Oh no. Which website is this? Well, I can tell you that this is Facebook. And do you know how much revenue Facebook generates? Well, the revenue it generates isn't that important because they serve 1.86 billion users. So when it comes to Facebook, the revenue doesn't matter that much, but the sheer amount of users that they serve is just immense. And Facebook is built using React. So the point is it's possible to build world's most demanding applications using either framework. This is a website made with Angular. You can go check it out. And it lists an exhaustive list of all the applications that are built using Angular. You can expand by Google section, and you will see 50 plus applications, and the list just goes on and on. Similar, Facebook on their GitHub site has a list, and that has about 700-800 entries in there. So a lot of people are using both frameworks. It's safe to say that they're kind of both popular. So, but what problems do they specifically address? And what are their appropriate use cases? For this, we must define the context in which you intend to use them. So the answer is it depends. All right, so get ready for a stormy ride. We're gonna get through this. So let's talk about the different kinds of contexts that exist. You could be using these frameworks in a single page application context, in a server-side rendering context, and also you may be using it alongside another MVC framework, server-side MVC framework, and we'll dig into what those specifically are. So in a single page application context, our pros are we distribute our executions because we ship our code to the user's browsers, and the code executes on their machine. Thus, we don't have to execute that code on our servers. And also because the code downloads ahead of time and it executes on the user's machine, it's a fast and fluid experience. And because we're using HTML, JavaScript, and CSS, it's considered a native web application. It's native to the web. It will run on any machine that's standards-based, and JavaScript really will run on any computer in the world, like from your refrigerator down to your car to anything you can imagine. So some of the cons, you can't control the user experience, right? Once you ship your code, maybe the person is still using IE6, and they're going to have a terrible experience. Their internet connectivity might be bad, so you might be shipping 10 megabytes of code, and it's going to take them 2 minutes to load that code. And Amazon measured every second of delay, actually every 100 milliseconds of delay in page load cost them several $1 million of revenue a month. So load times are important. And compatibility issues are also important. But it also depends on your audience. Are you targeting the entire population, or are you building a back office system where you can control that environment? So single page applications aren't just for web browsers. Sure, we can build native web applications, but there's this new concept of progressive web applications. Progressive web applications have native bindings. For example, when you go to a website, you might be able to install a shortcut directly to that website onto your phone's desktop or your PC's desktop. You might be able to leverage offline first functionality, where you go to the website even when you don't have connectivity. You will still see the page. You'll still see the last data that you pulled. So that's the progressive web. And then you can build hybrid mobile applications using single page applications. These are apps that you download through the app stores. And you can also build desktop applications. Who here has used Visual Studio Code? That's nearly everyone. And Visual Studio Code is actually written entirely in TypeScript. So it is a single page application, actually. So let's look how React and Angular apply to these targets. So we can do native web applications using Angular and React. You can do it. You can also build progressive web applications with Angular and React. For mobile, you can use Cordova, and Cordova basically wraps a browser in a native application environment. So if you can build a native web application, you can also build an Angular and React application using Cordova. Nothing prevents us from doing this. However, if you want a more ideal, more integrated experience, for Angular, you need to use Ionic. And for React, you need to use React Native, which is specifically purpose-built for hybrid mobile applications. And the benefit of hybrid mobile applications is you write it once, and you can ship an iOS app or an Android app. On the desktop, there's Electron framework, and it operates with a similar principle to Cordova. So it's possible to build desktop applications using Angular and React. But just because you can do something does not mean you should be doing it. So you should not be attempting to build native web applications using React, because React is a liar. Same goes with progressive web applications. And I'll go into why that specifically is. That's because it's Shadow DOM versus Virtual DOM. Has anyone heard of these things before? Okay, lots of blank looks. So Shadow DOM is this new web standard technology that hasn't been completely ratified and adopted yet. But what it does is your HTML is represented in a tree structure, which is called the document object model. And when you go ahead, like in AngularJS, you have bindings and you're updating things constantly, this triggers a complete traversal of that tree every single time you do anything. And this is highly inefficient, and this is why you see big slowdowns on large AngularJS applications. Shadow DOM is a way where you can kind of encapsulate parts of the DOM that you want to work on and update. It pushes it from the render pipeline, away from the render pipeline, into the background, and it changes what it needs to change, and then it surfaces back to the screen. So the browser only has to render it once, rather than if you updated it, several hundred times doing something, the browser doesn't have to spend time actually rendering that stuff. So this is like a web standard type of thing that is going into Chrome, Safari, Edge. Virtual DOM, however, is the same idea, that tree structure, completely done in memory. And then at the end of that process, it just spits out an HTML file. And this HTML file is just static. There is no JavaScript. There's no HTML5 like features in it. So Angular leverages the shadow DOM technology, and React leverages the virtual DOM technology. So I called React a liar because it basically invents its own web standard and does its own thing, and it's very efficient at doing it. But at the end of the day, it just treats the browser like a dumb, renderer, and it doesn't leverage any of the smart functionalities. So Shadow DOM is focused on scoping. So once you introduce some portion of CSS, you don't want that CSS to necessarily apply to, if you have a 300 view application, all 300 views. You just want it to apply to a particular component maybe. So Shadow DOM does this really well, and as a side effect of it, it is more performant. However, Virtual DOM was built with sheer performance in mind. And these are just the goals of these two different technologies. So this is really irritating stuff because it really goes into the core of what we've expected the web is or should be, and kind of puts a wedge in between that. As a result of this, the React HTML that's spitted out is not compatible with any of the developer tools that you know and love. So if you try to do like inspect element and in Chrome developer tools, go to sources and try to look at the HTML or try to debug it, you're not going to be able to do it because it's all going to look obfuscated to you. So really unnecessary stuff, like super unnecessary, like totally unnecessary. Like, why did I make that movie? All right. So that's our single page application context. This is client-side executed code. So now let's switch to server-side code. We want to be able to render server-side code for secure applications. For example, when you create a password reset request in an email and you click a link, you don't want to render the outcome of that at the client. You want to be able to render it server-side so that you can double check that the token you sent is valid, and then the page that you generate where the user enters their new password and all that stuff, you're under full control, and there's assurances that the user has gone to the right place, and you're not introducing any potential for an attack in there. So some of the pros here are a consistent user experience, because what you're doing is you're generating an HTML with a static HTML and just sending it down to the user, and this will render from IE6 to whatever. So if you're Facebook and you're serving 1.86 billion users, this is important. It's also consistent performance because it's just simple HTML. You could be using a small little netbook, if those are still a thing, versus a really powerful PC. The performance is going to be largely similar. But the cons are, you need a lot more server firepower. For Facebook, this is not a problem, but for your Small business or mid-sized business or enterprise, this might be a problem. It's also more bandwidth usage because we're sending the HTML and the data every single time down to the user rather than when we first send the code, that's a one-time overhead, and then we just exchange data back and forth. So there's more bandwidth being used here. And server-side can only target the static web. And this works fine with React. Actually, React is best in class for this. You can also do this with Angular using Angular Universal, which is a new part of the Angular platform. So you can do that. Now, we're going to go to the upside down. In fact, whenever my screen kind of goes black, there's one other instance. That means that we're kind of in a danger zone. We're going to talk about server-side MVC. This is ASP.NET, Java Spring, Ruby on Rails, Node.js, and Python with Django. It shares similar pros and cons to server-side, and it targets the static web. And you can do this with React. You can do this with Angular. But please, ever, never, never do this with Angular. I've seen someone try to put Angular 4 in an ASP website, and it was this entire platform rendering in every single page. So every single time the user clicked on something, it was just downloading megabytes and megabytes of JavaScript every single time. So it was like re-downloading the Angular platform for every single time just to show a few fields, basically. So Angular is really not suitable to mesh with those technologies that I just mentioned. But there's more. There's more to it. In server-side MVC, it's nearly impossible to separate concerns because you're putting either C# code or Python code or Ruby code or Node.js code intermingled with your HTML, CSS, and JavaScript. You can create really crazy scenarios easily where your code is going back and forth between the server and client, and you don't even realize it when you code this up. But then it becomes really difficult to untangle these types of situations. And you need people who really know what they're doing when it comes to dealing with these frameworks. And because of this, and because you can't really separate your business logic from your front-end code, working with these frameworks really corners you into a big bang rewrite that you have to do whenever you want to upgrade your front-end library. So I'll put up the slides on my website afterwards. I've written an article on this circa 2013. You can go ahead and read more details about that. Okay, so let's just don't do it. All right. So features. So we talked about DOM support. There's Shadow DOM, Virtual DOM, Angular does Shadow, React does Virtual. Targets, static, native, progressive, mobile, desktop. So React is good at static. Angular is good at native, progressive. You can use both for mobile, and you can use both for desktop. In terms of language support, so ES5 is the most widely supported version of JavaScript in users' browsers. So that's something that we have to keep targeting. However, ES 2015, aka ES6, but the numbered versions have been dropped. It's been switched to a yearly version scheme. So ES6 or ES 2015 contains a lot of developer niceties that we want to work with. Similarly, ES 2016 contains things like async await support. It's actually ES 2017, but same difference. So these are things that allow you to write simple JavaScript code. And there's TypeScript, which is a superset of all these versions of JavaScript. And in addition, it adds some type information if you want to into your JavaScript. So you can write Angular and React in ES5. React works best with ES6. Angular works best with TypeScript. Just because you can write your Angular and React in ES5 does not mean you should do it. So don't do it. And then you can use Babel with React to get ES 2016 support. So I'll get to what Babel and TypeScript is a little bit later. So let's talk about components, and let's dig into some code here. So components are, there's the web component standard that's being worked on. And the pie in the sky goal here is you write a component that's self-contained with its own HTML, CSS, JavaScript, and you can write it in any technology you want, and then you can use that component, take that component and use it in any other technology you want. So it's like a pluggable user control scheme. We're kind of far away from that becoming a reality though. So both Angular and React support components, but they're not web components really, because that's not a thing yet. Right? So components offer encapsulation of the behavior of the component. They are usually single purpose. So if it's meant to just render some page, it shouldn't be pulling data from the server. That should be the job of another component. They help you organize your files, so you don't have folders like HTML files, JavaScript files, CSS files, and then every time you want to change something, you're kind of going through folders and trying to find things. Whereas it's more organized like component A, and then it's HTML, JavaScript, CSS, lives side by side usually. And then they also promote reusability. So once you build a component, you should be able to easily use that same component in another part of your application, but perhaps feeding in different kind of data into it. So this should basically allow you to follow the dry principle, don't repeat yourself. And then they both offer templating. Templating is important because updating HTML from your JavaScript is really tedious manually. I mean, we've all done jQuery, I presume. So both Angular and React, they're trying to also solve that problem and making it easy to update your templates. So we have HTML standard, which supports shadow DOM, and then we have JSX. This is React specific. It's HTML-like, and it's purpose-built for the virtual DOM. So Angular supports that, React supports JSX. All right, so let's look at how an Angular component is built. So both Angular and React, because they are frameworks, they have some kind of a bootstrap mechanism where it needs to kick things off, bring together libraries and start getting ready to render stuff. So here with Angular, the core Angular platform is now a separate library, and on top of that you can bring in platform server, platform mobile, platform desktop. So in this case we're building a single page application for the browser. So we're bringing in platform browser. And then we're bringing in Angular forms. If you don't need any input, you can take this out. This saves several hundred kilobytes of that initial download you have to make. And then we're also bringing in the HTTP module so we can make server calls. And then we are importing our app component. So this is our first component that we load into the application, and then everything kind of fans out from there. So we define an ng module. So every component or everything in Angular is a module. So we declare an ng module. And then in here, we are saying, okay, ng module, you should know about app component. I intend to use it. And then we're saying, and also I intend to use browser module, I intend to use forms module, I intend to use HTTP module. There are also services that you can feed in here. And we're also saying, hey, that app component that I mentioned earlier, please use this to bootstrap the application and render the first page. So this is a little bit verbose and complicated, and it's for a good reason. Because Angular does what's called tree shaking. So if you think about the dependency tree of your application, and I have a visual of this coming up in a little bit, if you don't explicitly list forms module here, it's going to ignore the fact that you imported it here, and it's not going to include it into the final kind of compiled version of the application, thus saving a lot in size. So then, if we dig into the app component, here we are pulling in Angular core, but if you notice, so when you're importing with this new import syntax, there's several ways to import things. You can do import star as from Angular HTTP, and you can pull in the entire library, or you can pick out a specific thing that you're using out of it. This is also important for tree shaking, because if from Angular core the only thing you're ever using is component, once again, when it compiles the final version of your application, it's gonna strip away all those other parts of Angular core that you don't need, and it's only gonna give you what you need. So we declare a component, and I've intentionally have some commented out code here because there are multiple ways to write a component. So I'm trying to demonstrate how you can, in both Angular and React, your components can live in either one file, including the HTML and the CSS, or it can be spread across 3 files, .js, .html, .css. So here, we're defining our selector for this app, app-root. So this is what we define in our index.html, and that's how it knows how to bind this component into that specific HTML div tag that we might have defined to host our Angular application. So if I wanted to pull in my template from an HTML file, I would define a template URL just like this. Or if I want to pull in CSS or multiple CSS files into this component, I can do so here. Or I can just go ahead and declare my styles in here. If I'm just defining like one class, creating an entire file for this is a bit of an overkill. And here is kind of a view into that scoping that I mentioned with Shadow DOM. We can kind of define how we want the CSS here to be encapsulated, and we have different options there. And then this is an example of how we can define a template inline. So this is not a special syntax. It's just this backtick syntax is a new JavaScript ES6 feature for declaring strings, and it's just easier to work with than compared to just the single or double quotes you might use. But this is HTML with our regular, Angular binding happening. And here we can even define, hey, I intend to use some directives in this template. Please go ahead and import those directives into this component so that I can use those directives in here. But I'm not showing that here. And then at the very end of it, we finally define our component class. This is, if this is our view here, this would be our view model, if we were talking about it from an MVVM perspective. And here, well, all I'm doing is just setting title equals AppWorks, and then that just binds to this, and things render, and it works. You're going to have to take my word for that. All right, so now let's look into how a React component is defined. So this is the React Bootstrap code. Once again, we're seeing some similarities. We're importing React. We are importing React DOM because same thing goes for React. If you're building server-side versus browser-side, there are different kind of libraries that you need to work with. And then we're importing our app component. And then we're just calling React DOM.render and passing in this app component in there. And then we're just grabbing a div that we defined with an ID equals root. And we're telling React, please resolve what this thing is and put it into that div. So it's a lot simpler. Whereas in Angular, we had to use that magical Bootstrap setting. Here, it's a little bit more. You can see it working, the inner workings of it. And then this is our app component. So here we are importing component from React, where this sample also imports the entire React library in there. I'm not sure why. We're also requiring some image assets and some CSS. And then, so we're defining an app class which extends component. So that's kind of like an inheritance. And then every React component must define a render function. So if you're familiar with Backbone.js at all, it's kind of similar to that. Like every view has to have a render function. And then in here, we are returning, and it uses this special parentheses syntax, this HTML here. But really, this is not actually HTML. This is an HTML-like syntax called JSX. And what React does behind the scenes to this is actually it turns it into functions. So when we say, div class name app, what that does is React.createElement. Because we're creating a component, it has this notion. Anything that you create must start with a capital letter, so it knows it's not an HTML, native HTML element, but a custom component. And then we're saying, we're passing in properties into it. We're saying, please apply the CSS class app to this element. And then, comma, we're passing in another function, create a div, and then apply the app-header CSS to it. And then within that, create an element, img, and then pass in these properties. src should map to this.props.logo. Logo is the thing that we imported. Apply the CSS class app-logo, and then set the alt property to logo. And then at the most child root, h2 here, we're saying, okay, there are no further properties to pass in. And then we're setting the inner HTML to welcome React. And then the next element here is a p element with yay, it works. So if we go back and look into it, we're saying div, img, h2, p. So it's really, in terms of how it works at its root, it's quite different from each other. So, but this is not it. React also, to be able to understand the differences between the two frameworks, we need to also understand what Redux is. Redux is a predictable state container. So it's basically a data store that lives on your single page application. It is the single source of trust in the entire application. There is no other, because React components are completely stateless. You can't store state per component. You have to go to the single store to store things and read things from it. The state of React is read-only. You can't modify it. It has to come top down. And then changes are made with pure reducer functions. So you can't create a situation where you have some class variables and you have some functions and then you're changing those variables without passing them around. No, everything has to be passed in from function to function to function, and every function has defined inputs and outputs. So that's for React. You can use it for Angular too, but you don't really need it for Angular. With reactive extensions, you have you're programming with asynchronous data streams. This comes with the RxJS library. It introduces observables into your code, and it comes with a toolbox of functions that combine, create, filter these streams. So this is great for Angular. You can also use it with React, but once again, it doesn't really fit in with React. So Redux is a pub/sub event-based framework. You have your event source, and you subscribe to it like an on-click event, and then you say, okay, when clicked, call confirm save, and then you have your event handler confirm save. When the user clicks, the event fires, and then you can say, window.alert, are you sure? Right? And then also, you can have a single event source and multiple handlers, where you're publishing to multiple sources. So, for example, you have some updated data and you have multiple subscribers. This will simultaneously kick off the updates, and in one you could be, there's updated data, let me update the cache, and then there's fetch details for this data, or in another instance you could say show toast message. And the thing is, these things don't know about each other at all. They're just kind of like, okay, here's some stuff, let me work with it. So here's an example from a ToDo App, and so we are, pulling in React Redux here, and we're pulling in some actions. And what we're gonna focus on here is this to-do list component, because what this does is here we're seeing this map dispatch to props. Because remember, React has all those properties that it has to pass around, and it basically defines an event handler at the parent to do something when you've checked the mark saying you're done with a to-do item. So if we look at this to-do list, we're seeing that we're grabbing these to-do items, and then we're saying subscribe to the to-do click event, and then this eventually ends up firing this dispatch method, which hooks up to our Redux store and stores our data there. So it's when you're planning how you're building your Redux event or React Redux events or React structure, you really have to think backwards and forwards of how these things are working and make sure they all fit together. One nice thing about React is you can declare a property required, and if you don't provide it, it will actually complain at compile time, and it won't crash during runtime.
If we look at reactive or streaming programming, we start off with an event source that continuously emits events And along the way, we can have these functions that modify and shape the data into different forms.
So let's suppose we have mouse clicks going on. One function could be throttling those strips, those streams, and say like, I'm only interested in looking at this data every 250 milliseconds. Another one could say, please, from this event stream, pluck out list.length. So every 250 milliseconds, it's going to grab the amount of clicks. It'll be in a list and pass it into this function. And then that's just going to extract the length out of it. So if I did 1 click, it'll be 1. If I did 2, it'll be 2. If I did like 4, it'll be 4. And it'll put it into a nice list for me. And then I can add another function into the stream saying, OK, filter, and I'm only interested on numbers that are larger than or equal to 2. So what can we build with this? We can basically detect if the user double-clicked, right? And then we can pop up a window alert saying, are you sure? But the nice thing about streaming is we can also, in a completely different context, we can choose to do like an ng for loop and continually render these on a list and just show what type of data is coming through. And Angular has this new filter called async, which allows you to work with these streams, which may be emitting data or not emitting data whatsoever. So if we look at some code here, we're seeing, we're getting the button element, and then we're subscribing, we're listening to the click events coming from the button, and then we just write kind of clickstream dot, listen to the buffer, and in this buffer, throttle the results to, only return every 250 milliseconds, and then map these results and only return me the length, and then filter these and only return me the results that are greater than or equal to 2. And then at the end of it, we subscribe, like if this is successful, we can act on that. So a good example of this is when you have like on Twitter, you have a follow thing that has like only 3 elements. This is a continuous stream of suggestions that are coming from the Twitter service. Because if you say 3 follows, what's going to happen is you're going to get 3 more, and then 3 more, and then 3 more, and then 3 more. And it's just the way this is implemented is a lot simpler than if you would otherwise do it in a pub/sub method. So if you just think everything is a stream, everything is a stream. You'll be good. So no pub/sub events anymore. All right, it's kind of like this. Like everything is streaming constantly. All right, so let's look at some high-level code architecture at a mile-high view, how these things are coming together. So in every architecture, we're very familiar with this. We have a presentation layer, API layer, business layer, persistence layer. Then we have our IDs, best practices, patterns, libraries. And then we all have our testing suites, right? Automated testing suites? Yeah? No? All right. So we need to treat our front-end frameworks with the same respect we treat our applications. So every front-end has a view layer. This is your HTML. Has a view model. This is the JavaScript that drives the HTML. And then you have a controller or a router, and/or a router. And then all your HTTP calls, your local storage logic or business logic, they should live in their services. So if you have a piece of code that reads something off of an HTML and then calls an HTTP server and then goes ahead and changes some things more in the HTML, I mean, you can do all this in one function. You're violating the single responsibility principle in all different kinds of manners. So when your code breaks or becomes unmaintainable, you shouldn't be surprised that this happened. So We also have our IDEs, different kinds of IDEs that are good for front-end, best practices, patterns, and libraries. So it's really important to pay attention to these things and pick the right things, just as we pay attention to our back-end systems. And also, automated testing suites for front-end libraries are officially things, and you should invest time and money in that as well. So let's look at the anatomy of an Angular application. Every Angular application starts with a dash line. It's an animation error, sorry. So it starts with an app.ts. And then we create a router and we inject that into our app.ts. And then in our router, we define routes, right? So our first one is going to be /a. That's going to be our default one. And then this can include two components, a master and a detail view, in the same thing. And then with Angular, we also have services that we inject into app.ts, and filters and directives. And then we can have other routes that are connected to the root router. But then, there's my mystery -- arrow there. So everything that happened so far, when you build an Angular app, these have to be packaged in because you're referencing all of them at the root of your application. So it can't tell if you intend to use them or not. It thinks you're going to use them. So it includes all of those things in. However, in Angular, you can create these child routes. So in my router, if I define my route as /b/.. That's telling the router, do not attempt to traverse this tree. So what it can do is with Webpack, when you build the application, it will actually build it into two different components. So think if you have an application with like 5 modules, what can happen is in the initial download, it can just pull in the first megabyte. That's useful for the user to log in. And then, if they click on module A, it'll go ahead and download those 10 megabytes for that module A. But that one particular user may never, ever click on any of the other modules of the application. So you never actually download those into that user's browser. So this child route can have its own child router and children routes. But most importantly, and this is a huge boon for maintainability, it can have its own services, filters, and directives. So if you're defining filter services and directives that are just going to be used in a particular module, don't declare them and define them globally. This will actually allow you to have multiple teams working at a big Angular application and not collide with each other constantly. All right, so this is an example of a complicated Angular Bootstrap. So we're starting to see things like router. We're pulling in more modules and components that we're going to route to, and then we're defining more modules. We're telling our application we have a service now that we're showing. So this is how we're bootstrapping a more complicated kind of Angular application. But once again, it just defers to the app component to kick things off. So this is our app component. Actually, I lied. This is our routes. So here we import our routes somewhere. Let's say this app routing module here. So this is our app routing module where we're defining the routes of our application. So here we're defining what the path is going to be, what the component is, and then we're defining these outlets where they should render in. So if I have like that master detail view, I can direct them to, okay, you render in this div and you render in this div. And then we can define this load children attribute to load their child components or lazy load their child components, depending on what you're trying to achieve. and then so this .4 means it's a root router. So that's your top router. And then in our app.component file, we can go ahead and just declare kind of our home page, and we can just define router link, / crisis center, yada yada. So then when the person goes ahead and clicks on it, the router resolves the links and then displays the correct thing. So it's kind of how an Angular app is put together. With React, so we talked about components, but there are multiple types of components in React. There are presentational components that only worry about displaying things, containers that pull data from the store, provider wraps things like Redux and makes it available to the entire application, and there's also a special router component that handles routing. So with React, we have a perfect mathematical tree at play here. So everything starts with app.js, and then we inject React Router into it. We inject React Redux into it. So these are like all parent elements that are wrapping all the other elements. And then we can have a view with a presentational and a container component that's going to render something interesting and display some data. Or we can, have multiple views. So this could be, on the left could be my master, and on the right could be my detail. And I can have multiple presentational components. If my detail view has, multiple tabs, those can be different components. But as you see, this is like a very, mathematical tree. Whereas if we go back to here, there's dependency injection going on here. These services, filters, directives can be used by, these child components, and they're not really, perfectly linked like in a React application model. So the provider component, because it's so tedious to have to push down properties to every element and then push them back up, it actually offers a bit of a cheat where it makes it possible, it automatically passes things in for you. So from the user's perspective, from every container element, you can reach this Redux container without having to go through some gymnastics. So the Bootstrap code looks the same. So this is the benefit of React. As your application gets more complicated, this stays kind of the same. And then here we have router that we're importing. And then we're importing our child components that we want to render. And then on our app component, we just, using this link component, we just link to them. And then here, this is where we define our routes. So that it knows when it gets, /about, that it's supposed to render the about component. So it's kind of easy to learn React in a day, but it kind of takes a lifetime to master, sort of a thing. All right, so let's talk about tooling real quick. This includes CLI tools, transpilers, code editors. So if you want to start off with a React app, you want to use the Create React App tool. It's very simple to use. You npm install -g, so it's globally available through your command line. And then all you got to run is create React app, my app, which will scaffold a basic React application in a folder for you. So then you just cd into it, and then you run npm start, and then that actually spins up a server automatically for you. And it's pretty neat. As you change your code, it automatically updates. If you mess something up, it tells you what you messed up. It's a pretty nice and lightweight development experience. Angular also has a CLI tool at cli.angular.io. It's called ng. So you go ahead and install it with @angular/CLI, and this gives you the ng tool on your command line. So you can do ng new my dream app. It'll do the same thing, and then you use ng serve, which then serves up the application with a browser for you. And it's kind of similar, and as you type an update, it updates for you. That's also a pretty nice experience. However, the ng CLI tool goes a step forward. Because it can be a bit of a pain to set up all those complicated routing structures and components in Angular, they've actually included some commands in there where you can just say ng generate component my new component, and it'll go ahead and automatically scaffold the files for you. It'll add unit tests to it. It'll wire up the routing for you, so you don't have to do it. And this ng-g is just like the first letter of generate. So you can just do, you don't even have to type out component here. You can just say like ng-gc my component, my new component, and it'll do the same thing. And here, it's showing you how you can generate child routes versus parent routes. So it's a pretty neat tool. In terms of transpilers, so transpilers converts the more advanced or newer JavaScript that developers like to ES5 or lower that's compatible with people's browsers. So React, so there's Babel and TypeScript out there. React uses Babel, and Angular uses TypeScript for this. So if anything, you'll see with React, it's a mishmash of kind of tools that are being brought together, whereas the Angular story is really an easier story to tell because TypeScript kind of does a lot of things for Angular. And in terms of code editors, you can pick whatever you want. I forgot to include Vim because I can't imagine how people actually use Vim to develop. So, but my favorite is Visual Studio Code. It works equally well with Angular and React. And then there's WebStorm as well, but that's more of an IDE, whereas Visual Studio Code is the best of both worlds. It performs like a code editor, so it's super fast, but it also has IDE-like features. In terms of tools, sadly, you need to go ahead and download the React Developer Tools for Chrome to be able to actually debug and inspect your React application. And an honorable mention here goes to Angular Material library. I highly recommend that you look into Angular Material. It's a collection of rich user controls that you can drop into your application. By using this, you can pretty much avoid having to write complicated HTML or like CSS altogether. It's a big difference maker when it comes to Angular. So then, when we look at the support scheme, so we have Google, Microsoft, Facebook in play here. Google does Angular, Microsoft TypeScript, Facebook React. In terms of documentations and tutorials, just go to Angular docs. There's quick start tutorials that you can use it to get ahead pretty quickly. React has similar, equally well documentation and tutorials that you should do. In terms of licensing, Facebook does BSD, which means if you ever become Facebook's competitor, they have the right to pull their React license from your application, so you'd have to rewrite it completely. Whereas Google ships an MIT license, you can do anything with it. So in terms of community, there are rich conferences, Twitter activity, GitHub projects, pull requests, issues. You can go ahead and create your local meetups that you can engage with. In terms of learning resources, please pay attention to documentation and official tutorials. There are lots of craft out there that pull in random things. And there's Egghead.io. It's a great resource for learning any of these frameworks from scratch. And then my website, thejavascriptpromise.com, that has some useful information to get you started and good at JavaScript. So we looked at the purpose, context, features, code architecture, tooling, and support across all these frameworks. There's one last thing. The best feature of Angular 4 is that it's in long-term support until October 2018. This is unprecedented when it comes to an open source JavaScript library like this. So you can actually count on timed releases and an actual support window and plan your upgrades. And I actually just wrote a blog post on this that you can check it out at this link. So Angular versus React, which one is better? It depends. It depends on your context. It depends on your preferences. Really, they're both pretty awesome tools. So just pick which one is going to make you happier and which one is going to make you be that woman right there. If you try to do everything, you're going to become master of none. So just pick your tool and use it. So the slides are going to be up on, not yet though, in a few hours on the javascriptpromise.com. And follow me at Uluca. Thank you.